class E-type chopper. Now this E-type chopper is a 4-quadrant type chopper. So it can be operated in any quadrant. Now this E-type chopper is a parallel combination of two C-type chopper. The combination of thyristor T1, T4, D2 and D3 which forms one C-type chopper, and another is formed by thyristor T2, T3, D1 and D4. So here you can see that there are two C-type choppers which are connected in parallel, which makes E-type chopper. So here you can say that this E-type chopper consists of 4 thyristors and 4 diodes which are connected in anti-parallel to each other. Now first we will see the first quadrant operation. So in this type of first quadrant type operation, your thyristor T4 kept on condition, and thyristor T3 it is kept in off position. Suppose if this T4 is on and that time T3 is also on, then this DC source is short circuited by this 3 and 3 4. So that's why it is most important when your T4 is on, that time your thyristor T3 must be remains in off condition. Now so here that's why this T4 is kept on, T3 is off and T1 is operated. That means in first condition your T1's in on condition and after it will turn off. So first we will see your T4 is kept on condition. That means it is short circuited, and T3 is off, T2 is already off, diode D1, D2, D3, D4 are in rest off condition. Now when this T1 is turned on, that means T1 is turned on. So the input voltage Vs is applied across this load. That means the output voltage across the load will be equal to the supply voltage Vs, and its polarity is positive. Now due to this voltage, the current I0 will start to flow from source to load, and its path is from plus Vs to thyristor T1, inductor, then load, that means motor, and then T4, and then negative Vs. So this is the direction of current flow from the load. So you can say that your output current, it is also in forward direction. Now when your T4 is still on and T1 is kept off condition, that means this T1 is in off condition. So now when your T1 is turned off, the current passing through this inductor decreases, which makes high reverse voltage induced in the inductor. That means your right terminal becomes positive and left terminal becomes negative. So now due to this voltage, due to this reverse voltage, will turn on the diode D2. That means it acts as a short circuit, and so now due to this reverse voltage, current is start to flow from inductor to motor to T4 and diode D2 and then inductor. So here the direction of current is similarly to the current passing through this load when your thyristor T1 is on. So you can say that in this both condition the output voltage is positive and the load current, it is also positive. That means it is operated in the first quadrant. Here your output voltage is 0 when T1 is off, and here when T1 is on, that time our output voltage is equal to supply voltage Vs. Second quadrant operation. Here thyristor T1, T3, T4 is kept in off condition where T2 is operated. So now first when T2 is kept on condition. So now when T2 is on, that means it treated as a short circuit. So now due to this back EMF of the loads, which will turn on the diode D4, and therefore a current is start to flow from inductor L to T2, then diode D4, and then motors, and then into the inductor. Here the output voltage across the load will be 0. So now you can see that the current is flow from right side to left side. That means it is in reverse condition. So it is most important. Output voltage is 0 and current is negative. Now this T2 is turn off. That means when current passing through this inductor, there is some energy stored during when your T2 is on. Now when T2 is off, that means T2 is off, that time the current passing through this inductor is decreased due to very large reverse voltage appear across the in the inductor L. So its right terminal becomes negative and left terminal becomes positive. So you can say that your output voltage is equal to VL plus EB. VL, that means voltage available induced in the inductor L, and EB is the back EMF of the motor. So now this voltage V0, which will turn on the diode D1. So now you can say that your output voltage is greater than input voltage Vs. So now there will be a load current I0 is flow from inductor L to D1, then positive Vs, then negative Vs, and then it is passing through the diode D4, then a motor, and in the inductor. So here you can say that your our output voltage is positive because this is higher potential and this is lower potential. Here your output voltage is positive, but the current passing through the load is negative. In this case, your power can be transferred from load to source. So you can say that in this both condition, when T2 is on or off, your output voltage remains positive while the current passing through load is negative. That means this chopper is operated in the second quadrant. Now then we will see third quadrant operation. Now in third type quadrant operation, your T1 is kept in off condition, T2 is also kept in on condition, and T3 is operated. That means T1 off, T2 is kept on in both condition, and T3 is operated. Now when first T3 is in on condition, that means T3 is in kept in on condition. So now it is turn on, that means T3 is short circuited. So now you can see T2 is already on, T3 is already on. So the input voltage Vs appear across this load, but you can say the polarity is reverse. Right terminal positive and left terminal negative. That means you can say that your output voltage is equal to minus Vs. Now due to this voltage, current I0 will flow from source to load, and its path is positive Vs to thyristor T3, then motor, inductor, then thyristor T2, and negative terminal of the source, or you can say minus Vs. So you can see that your output voltage is negative and your load current, it is also in negative direction. Now when T3 is kept off, so now when T3 makes off, that now during this time some energy storage in the inductor. So now when T3 is kept off, that means it is disconnected from the supply and current start to decrease. Now when the current start to decrease, a very reverse voltage induced in the is inductor L, and its right terminal becomes negative and left terminal becomes positive. So now due to this reverse voltage, it will turn on the diode D4. That means this diode is treated as a short circuit, and now then current flows in the circuit through the path inductor to thyristor T2, then diode D4, and then motor, and then into the inductor, and the output voltage across this load will be 0. So you can say that in this condition output voltage is 0, but the load current it is in negative direction. So in the both cases you can say that your output voltage is and the load current both are negative. That means these types of chopper is operated in the third quadrant, where your voltage, output voltage, and the load current both are 0. Fourth quadrant operation. So here we are assuming that our motor is operated in reverse direction. So here we are reverse the direction of back EMF. So it is most important point in this fourth quadrant type operation. So now in this fourth type quadrant operation, CH4 is operated and other remains in off condition. So now when CH is kept in on condition, that means CH4 is in on condition. So now due to this back EMF, which will turn on the diode D2, because this is your positive terminal and the negative terminal. That means it is forward bias and it is turned on and it treated as a short circuit. So now due to this current flowing through this circuit, load current flowing through this circuit from back EMF to TF4, then D2, then in inductor L. So now you can see that the output voltage across this load is 0, but the load current passing through this load is positive. So and when the current is passing through this inductor, some energy stored in this inductor. So you can say that your output voltage is 0 and the current is in positive direction. Now when this CH4 is turned off, so that means the current passing through this inductor is reduced, which induce very large reverse voltage in the inductor. So its right terminal becomes positive and left terminal becomes negative. So your output voltage becomes V0 is equal to VL plus EB. VL, that means voltage induced in the across the inductor and the back EMF of the motor. So now this is output voltage is greater than source voltage. And now you can see that now this voltage will turn on the diode D3. D2 is already turned on. So now the negative voltage applied across the load. That means this terminal is positive and negative. That means your output voltage is reversed. That means it is in negative. And in this case, the current start to flow from load to D3 to plus Vs or DC source, then minus Vs to D2, and then inductor L. So you can say that the load current it is in positive direction, but the power in this case the power can be transferred from load to source. That means you can say that the output voltage is reversed and the load current is positive. So in both cases your output voltage is negative while the load current is positive. So that's why this type of operation or circuit is operated in the fourth quadrant, where output voltage is negative and load current is positive. So now in this E-type choppers forms two bridge. One bridge is called forward bridge. It is formed by T1, thyristor T1, thyristor T2, thyristor T3 and thyristor T4. Now during this operation, or you can say that the flow of power is positive or forward. You can say that in this case, when this bridge is operated, your power is flow from source to load, and another bridge forms due to the diode D1, D2, D3 and D4. It is called reverse bridge. Now during this operation, your power can be flow from load to source. So it is most important. So this is the forward bridge and the reverse bridge. So this is a totally four type operation can be operated by the E